Okay, hello. This time we're going to discuss about multiplying exponents. Our main objectives here is to multiply powers with the same base. Okay? So we have here, before discussing further, we need to review exponents. 5 raised to 3. Let us identify what is 5 and what is 3. 5 is what we call the base, and 3 is what we call the exponents. So 5 raised to 3 is what we call power. Okay, so example here, 125 is equal to 5 raised to 3, means that 5 raised to 3 is the exponential form of the number 125. Therefore, 5 raised to 3 means 3 factors of 5. Or we can say that 5 is to be taken 3 times as a factor, meaning 5 times 5 times 5, and that is equal to 125. Okay? So we have here the first law of exponents that we're going to discuss, multiplying powers. And here we're going to simplify it in order for everybody to understand it. If you are multiplying powers with the same base, we have there, keep the base and add the exponents. Okay? So again, if you are multiplying powers with the same base, we're just discussing the same base. Keep the base or copy the base, and then you're just going to add the exponents. Example, we have here x raised to m multiplied by x raised to n. The base here is x. The base here is also x. Remember, this law is only intended if the operation between the expression is multiplication. So since they have the same base, it says there you're going to keep the base or copy it. Copy the base, x times x, so that is x. And then what are you going to do with the exponent? The exponent here is m and the exponent here is n. It says there you're going to add. So in layman's language, with this law of exponent, it says that copy the base and add the exponents. That's it. Okay? Let's take some examples. We have here 2 raised to 6 multiplied by 2 raised to 3. So we now have, since they have the same base, 2 and 2, you're going to copy the base and then add the exponent. 2 raised to 6 multiplied by 2 raised to 3. So you now have 6 plus 3, and that is now equal to 2 raised to 9. Okay? So that is the simplified form, 2 raised to 9. Okay? There are instances that you are asked to give the value of 2 raised to 9. So what is the value of 2 raised to 9? So that is equal to 512. 2 raised to 9 does not mean to say that 2 times 9. No. It means that you're going to multiply 2 9 times by itself. So you now have 512. So that is the value of 2 raised to 9. Next, we have here 12 raised to 4 multiplied by 12 raised to 3. The operation between them is again multiplication. They have the same base, 12 and 12. So you now have 12, just add the exponents, 4 plus 3, and that is equal to 12 raised to 7. Again, there are instances that you're going to give the value of 12 raised to 7. And what is the answer? What is the value, I should say? We have here 35,831,808. Okay? The next one, we have here negative 5 raised to negative 2 multiplied by negative 5 raised to 7. They have the same base, negative 5. So you now have negative 5 raised to negative 2 plus 7. Always remember that if ever you are adding, always apply the rules in adding integers. The sign of your 2 is negative and the sign of your 7 is positive. So you now have negative 5 raised to 5. What are you going to do? You're going to subtract. 7 minus 2 is equal to 5. So that is now the simplified form of the given expression. Again, what do you think is the value of negative 5 raised to 5? That is equal to negative 3,125. Okay? So let us discuss further examples. What is its expression written using its base only once? Okay? So we have here 8 raised to 3 multiplied by 8 raised to 6. Based from the first law of exponents, they have the same base, just copy it. And then, what are you going to do with the exponents? You're going to add it. So, 3 plus 6 is equal to 8 raised to 9. We're just going to end up here because of the question here. Okay? The next one. 0.5 raised to negative 3 multiplied by 0.5 raised to negative 8. Again, copy the base since they have the same base. 0.5 raised to negative 3 plus negative 8. Okay? So you now have there 0.5 raised to negative 11. Okay? Now, what have you observed about the exponent? What is the sign of the exponent? It is negative. We're now going to end up there. We're not going to end up there. Always remember, what is the denominator here? It is 1. We're going to express our final answer wherein the exponent is positive. So we're going to follow the rule. We now need to move 1 up and then move 0.5 down. And then what will happen to the exponent? Change it. It will become positive 11. Okay? So that is now the simplified form of number 2, making the exponent positive. Okay. The last one we have here, 9 raised to negative 3 multiplied by 9 raised to 2 multiplied by 9 raised to 6. They have the same base. All you need to do is copy the base. And then, how about the exponent? Negative 3. Again, since they have the same base, you're going to add the exponents. Plus 6. Always remember that you need to follow the rules in adding integers. Negative 3 plus 2, that is negative 1. Negative 1 plus 6, that is equal to positive 5. So, the answer there is 9 raised to 5. Any more question? Okay? So this time we have here multiplying powers in algebraic expressions. This time a little bit difficult because aside from the variables, we're now going to be concerned about the coefficients. So we have here 4 z raised to 5 multiplied by 9 z raised to negative 12. So how are we going to simplify this one? Of course, we're going to concentrate first on the coefficients. We're going to multiply 4 and 9. So 4 times 9. And then concentrate on the variables. Z raised to 5 multiplied by Z raised to negative 12. What is 4 times 9? That is equal to 36. And then, what are we going to do with the exponent of Z? They have the same base. Copy the base. So you now have here 4 times 9, that is 36. Copy this base, which is Z. And then, the exponent is 5 plus negative 12. Okay, always remember, you need to apply the rules in adding integers. So you now have 36 Z raised to negative 7. 5 is positive, 12 is negative, so you're going to subtract. 12 minus 5, that is 7. Since the absolute value of 12 is greater than that of 5, so the sign of 7 is negative. We're going to follow the sign of 12. Okay? Again, as what I have told you, we have here the exponent of Z is negative. We're going to finalize our answer. So you now have 36. Since Z is on top, we're going to move it down, making the exponent positive. So the final answer is 36Z raised to 7. Okay, the next one we have here. Okay, 2A multiplied by 9B raised to 4 multiplied by 3A raised to 2. So again, let us concentrate. What is the exponent of A here? It is 1. So let us concentrate first on the coefficients, 2, 9, and 3. So you now have there 2 times 9 times 3. And then we have there A raised to 1 multiplied by A raised to 2 multiplied by B raised to 4. We will group A together because they have the same base. Then now we have 2 times 9, that is 18, times 3, that is 54. Since they have the same base here, you're going to add the exponent, 1 plus 2. Then just copy B raised to 4. So you now have 54, A, 1 plus 2, that is 3, and then B raised to 4. So that is now the final answer. To discuss this better, let us try to answer some examples. We have here now letter A. Letter A is 5x raised to 4 multiplied by x raised to 9 multiplied by 3x. Okay, what is the number here? It is 1. And here, what is the exponent of x? It is 1. Okay, let us concentrate first on the coefficients. Let us multiply the coefficients. 5 multiplied by 1 multiplied by 3. And then after that, concentrate on the variables. We have there x raised to 4 multiplied by x raised to 9 and then multiplied by x raised to 1. Okay, let us now multiply. What is 5 times 1? 5 times 3, that is now equal to 15. And then how about the variables? X. You're just going to add 4 plus 9, that is 13, plus 1, that is 14. Okay? Any question? So you're just going to do that. It would be better for you to do one at a time. Okay? Because math is an exact science. So any more question?